So as Hugh said, today I've been asked to talk about basically all of our sorghum research in 15 minutes. So it could be a quick 15 minutes, but I suppose Guy, McMullen and myself, who are based out of Tamworth and New South Wales DPI, thought that we would probably be best covering off just on 2 of our sorghum research projects and probably giving you a bit of insight into those rather than trying to cover absolutely everything. So the 2 aspects that I've chosen to talk about today is firstly a project based in the medium to high yielding zone. So we're talking about Liverpool Plains, and so we'll be talking about a site based at Breeza last season, so the first year of trials there under the high yielding cereal agronomy project. And that site was one of 2 last year that we had on the plains. I'm just going to talk about Breeza today though, because it had both a dryland and an irrigated trial at the same site. So there's some good comparison there from those 2 different trials. And then secondly, I'll be talking about some more comprehensive research that we've had underway for the last 5 years in this area here west of the Newell Highway, and that's under the Sorghum in the Western Zone project. And I'm sure many of you have heard components of that over the last couple of years, so it's really a bit of an update as to what's happening now. So if we started off with the medium to high yielding zone, so really we're talking about a research project there that's actually targeted at an area where sorghum is an integral part of the rotation. So it's an area where growers are comfortable growing sorghum, they know it's profitable, it's a major part of their rotation, and the yields that they get are good. The focus we're putting on it though at the moment is how much better could we make their yields. So we know currently at Gunnedah the long-term average yields are just under 4 tonne to the hectare. But we also know that from dealing with growers, commercially they've been able to achieve up to 12 tonnes to the hectare in dryland situations. So you can see that there's a pretty large gap there between what the average yields are and what potentially we know that growers are able to achieve. So the aim of this project has been to actually start to break down and partition what we're doing with our crop management and what the different contributing factors are to actually achieving those top end yields. So as part of that, we've designed a series of experiments. The experiment at Breeza last year was made up of a combination of 24 different treatments. It was a partially factorial trial, and that's really just because if we had the whole combination of all of the treatment options, it would really be prohibitive in terms of size. So last year at Breeza, we had both the dryland and the irrigated trial, and we included a range of different factors. So we included a time of sowing component. So we started with an early or an ideal timing at the end of October, and then we included a late time of sowing, so a time of sowing 2, which was actually in the first week of December. Then we've overlaid on top of that a hybrid component. So we selected 3 hybrids. We chose Buster because it's a commercial hybrid that people are very comfortable with. And then we selected 2 new release hybrids or recent release hybrids. So in this case, we actually used MR Scorpio from Pacific Seeds, and we used 85G33 from Pioneer. We then included a range of different plant populations, so 50, 75 and 100,000 plants to the hectare. And then on top of that, just to make it a little bit more complicated, we included a row configuration aspect. So at our Breeza research station last year, we were on 1.8 metre raised beds. So we included a 90 centimetre solid row spacing. And then we also included a twin row spacing component. So with the twin row spacing component, what we actually did was planted an additional 2 rows inside the 90 centimetres, so there was 7.5 centimetres or 3 inches between the 2 rows, so quite close together. We also tried to include some of the nutritional aspects. Obviously, there's a wider range than just nitrogen and phosphorus, but for the largest yield benefits, I suppose looking for the biggest return on your investment, we included 3 rates of nitrogen, so 0, 100 and 200 kilos of N to the hectare, and we included 3 rates of phosphorus, so 0, 10 and 20. And both of those were applied at sowing as urea or as triple superphosphate, so just as single nutrients. The irrigated trial had 2 irrigations, and the timing of those actually ended up being on the same dates for time of sowing 1 and 2. And that was really just because we had rainfall earlier on in time of sowing 1, so it didn't need an irrigation prior to that point. The site itself actually was quite low in nitrogen, so as you can see, about 46 kilos of nitrogen down to 1.2 metres, and a reasonably good profile of about 187 mils of plant available water for sorghum. So let's look at the results. So if we started first with looking at the effect of time of sowing, so what was the difference between that ideal sowing at the end of October and then delaying it kind of that 6 weeks until early December last year? So these graphs have the plant population component included as well. And so you can see the significance letters there. If we look first at the dryland graph, where basically our average yields are just over 3 tonne to the hectare, about 3.4 tonnes to the hectare, what we can see is that time of sowing 1 yielded more than time of sowing 2, but only at the higher populations, so only at the 75 and 100,000 plants to the hectare. There was no difference at the 50,000 plants to the hectare between time of sowing 1 or time of sowing 2, so they yielded the same. In contrast, at the irrigated site, where you can see our yields have lifted to our averages being closer to the 6 tonne to the hectare mark, there was no difference in the time of sowing last year. So if we then tried to break apart our row spacing and what are the contributions to yield there from varying our row spacing, what we saw with the dryland trial was that the 90 centimetre solid rows out-yielded the twin rows at both times of sowing. So it was a pretty clear response there. It was a little bit more complicated with the irrigated site. So with the irrigated trials, both the 90 centimetre row spacings for the time of sowing 1 and 2, so both times of sowing, yielded the same, and the twin row spacing for the first time of sowing also yielded the same. But it was the twin row spacing on the second time of sowing that actually yielded significantly less. So a slight reduction there. But overall, as you can see under the irrigation, not a major impact on yields from the different row configurations. So we moved across to hybrids. So obviously there's a lot of focus from growers and advisors on picking the right hybrid each season and a hybrid that's going to yield the best. As I've outlined, we chose MR Buster because it's a commercial standard, and then we chose 2 recent release hybrids because we're looking to see if we could actually show the genetic gain from the newer hybrids coming out onto the market. So with G33 and Scorpio and Buster, we put them all under the same treatment conditions. So we gave one set of treatments where they were all planted at 50,000 plants to the hectare, a 90 centimetre row spacing, 100 kilos of nitrogen and 10 units of phosphorus. And then we compared their yields. What we saw last year, and you can see from how close these bars are together, probably even before I put up this next bit, is that there was no significant difference between any of the hybrids last year under the dryland or the irrigated trial. So if you're looking at the partitioning of yield so far, we can see that the hybrid selection hasn't actually added a lot in last season's trials. But what has had a major impact last season has been our crop nutrition. So we've got the largest response to nitrogen in terms of varying our treatments. So as I mentioned, we started with quite a small amount of nitrogen in the profile, only enough to actually yield about 1.5 tonnes to the hectare, and that's excluding any mineralisation that occurred in season last year. It was quite a dry season, as many of you will probably recall. And then over that low starting end, we added the 3 treatments. So we added a 0, 100 kilos and 200 kilos. So we added enough nitrogen in essence to target about a 7.5 tonne per hectare yield. Pretty clearly you can see that in the dryland trial on your top left there, that our best response was from applying the 200 kilos of nitrogen to the hectare. So in essence, we've taken it from between 2 and 3 tonnes to the hectare up to nearly double that from the addition of 200 kilos. Similar story with the irrigated trial, only obviously our yields were higher, but still a fairly large response to that 200 kilos of nitrogen. The question that obviously sticks in my mind, and hopefully is in your mind from looking at this line, is what would have happened if we'd applied additional nitrogen. So we didn't top out the trial there, so was there potential to actually lift those yields further by applying a higher rate? The other question is obviously about the economics. So just to horrify the economists in the room, did a quick back of the envelope calculation. Last week at Werris Creek, sorghum was $250 a tonne. Urea in Tamworth was $645 a tonne. So it actually worked out to be an $875 profit from applying that 200 kilos of nitrogen compared to our nil treatment. With phosphorus, the story was a little similar, but not quite as clear. So what we saw with phosphorus was that when we applied just 10 units of phosphorus but no nitrogen, we didn't really get a very significant response. Certainly under the Dryland trial, we didn't get a significant response at all. In the Irrigated trial, it was a little better. But the best responses were in combination. So when we actually added nitrogen and phosphorus together, that was where we had significantly higher yields. Again, as I said, in the nitrogen, the beauty of hindsight is that you look at these treatments afterwards and think, wouldn't it have been nice if I'd had just 20 kilos of phosphorus by itself as a treatment alone? But can't have everything, Guy keeps telling me. So from that medium to high yielding zone, what are the take-home messages? First up, 1 year's data, so it's a preliminary trial set, so please keep that in mind. Obviously we've got trials underway this season, so there'll be additional data to go with it. At this stage, the early planting time has been higher yielding, and we've seen that significant response to population as well. So 75 and 100,000 plants per hectare have been higher yielding than our 50,000, which is what we're currently focusing on. There was no significant difference between the hybrids last year, but we did have a very strong response to some of the nutritional components. So if you were going to be making an investment at the moment, nutrition appears to be one of the best responses that we could look at. And finally, if we looked at row configuration last year, there wasn't a major response in terms of our yields. There were differences, but they were quite minimal. If we skipped then to the other project, so now looking at the sorghum in the Western Zone project here, which has been running since 2010. So this is a bit of an overview of what's happened over the last 5 years. As a bit of a refresher, or for those who haven't seen any of this work before, this project's focused on that low to medium yielding environment. So all the trials are west of the Newell, and over the last 5 years we've had 9 successful dryland trials. We have planted a couple of others which have either succumbed to flood, which is probably a little hard to believe at the moment, or drought. So last year we lost a couple of trials through to extreme drought. Of the 9 successful trials, we've overlaid a series of different components. So we've called these the GEM trials. So we've combined the genotype differences. So there was 3 hybrids that were selected for their characteristics, not for the specific hybrid. So we used 2436, which is an experimental line, and it was selected because it's low tillering but has high stay green. We used MR43 because it's a moderate tillering and moderate stay green, so it's that kind of middle of the road. And then we've used MR Baisley, which is high tillering but low stay green. So you can see it's the contrast to 2436. As I've mentioned, we ran the Western environment, and then we've overlaid a series of management factors. So we've run both early and late plant trials depending on the season and the site availability. And then we've included 4 different plant populations, 15, 30, 50 and 70,000 plants per hectare, and 4 different row configurations. So a solid 1 metre, which is obviously not very common in this environment, a single skip or a 1.5 metre solid plant, which we refer to as a super wide, and then a double skip.
5 minutes.
Cool. So if we look at the results here, a couple of quick slides to give you an overview of what's happened. Firstly, the plant population. So in the first couple of years, we ran 30, 50 and 70,000 plants per hectare. In those first years, which have been obviously very high yielding compared to what the average is in many of these environments, so where some of the plots were going 6.5 tonne to the hectare, what we saw was that the 50 and 70,000 plants per hectare were always higher yielding, and generally there was no difference between those 2 high populations. The 30,000 plants per hectare was never able to compete in that situation. So what we then revised was, well, why would a grower want to plant 70,000 plants per hectare? Because it was going to be an additional seed cost if they actually weren't going to get any additional return. So we removed the 70,000 plants per hectare and replaced it with a lower plant population. So from 2012-13 season, you can see here we've started to include this mauve bar, which was 15,000 plants per hectare, which is a fairly common question from growers, particularly in the Walgett and Rowena area, is how low can we really go? So we thought we'll try and capture some data from that very low side of the spectrum as well. What we've seen over the last couple of years, with the exception of the site at Taloona last year, which you'll see keeps reappearing in the coming slides here, as a very low yielding site, just over a tonne to the hectare, and very unresponsive to pretty much any change in treatments. But with the exception of Taloona, what we've seen so far has been that 30 and 50,000 have been more comparable over the last couple of seasons, and the 15,000 is really the treatment that hasn't been able to compete. So to date, we're still recommending to growers that they'd be best targeting their populations around the 50,000 plants per hectare, and if they were going to go lower, then it would be down potentially to 30,000, but we're still more confident in the 40 to 50,000 plants per hectare in that environment. If we looked at row configuration, it's been a fairly clear story over most of these sites as well, with the exception, as I said, of Taloona, the thorn in the side here. I just had to include it though. What we've seen over the last 5 years has been that our solid plant configuration has consistently out-yielded any of the other configurations. Keeping in mind that that solid plant is a very high risk option for growers in that environment, because typically they're not expecting to be yielding 5 tonne to the hectare each season. The solid plant has always out-yielded the single skip and the 1.5 metre solid, and they've been comparable as treatments, and they've all out-yielded the double skip. If we actually moved on to comparing the configurations as effective row spacings though, we start to see probably an easier trend. So what we've done here is, if you look at solid plant as your 1 metre effective row spacing, and if we considered that to be our 100% yield potential, and then our 1.5 metre row spacing is the single skip or the super wide treatments, and the 2 metre is our double skip treatment. What we can see here is that for growers who were using or are using double skip at the moment, pretty much what we've seen is that on average they're sacrificing around 34% of their yield potential in these high yielding seasons. Some of the sites it's been up to 50%. In contrast, the single skip or the super wide has on average been sacrificing 17%. Now the question really needs to be raised then about how many people would want to go for this top end yield potential, but also consider how high risk it is. And I think that's probably an important message, is that while this can look very attractive, it's also extremely high risk. And so I think really the area of interest is going to remain here in this 1.5 metre row spacing. And we've seen probably more growers and advisors shift to that in the last couple of years, particularly because of the high yielding seasons, but also the 1.5 metre solid offers you a much more even plant configuration across the paddock compared to a skip, where, for example, with the double skip, you're only planting half your paddock, and with a single skip, obviously, you're still leaving large bare areas in your paddock to actually manage. Of course, we wanted to look a bit at the economics, and so Fiona Scott, who's an economist with us at Tamworth, has run most of our trial sets. I just pulled out one of her graphs to pretty much illustrate one simple fact. With sorghum, it's all about yield. So if you want to make more money, you need to get higher yields. And that's basically the story over a range of different seasons. If we went to hybrid selection, just to look at the genotype interactions here, what we've seen is that where we've used the low tillering hybrids, they have never been able to compete with the moderate or high yielding, high tillering hybrids that we've included. So basically, hybrids that have some level of tillering capacity have been able to respond to the variable seasonal conditions that we've seen. And so that compensatory mechanism is very important for us actually maintaining and trying to actually achieve our top end yield potential. So at this point in time, looking at the take-home messages from that project, What we've seen has been that the early planting for sorghum in the western zone is still better than the late planting. Now, I haven't included that data today, but what we've seen has been a yield benefit from the early planting compared to the late planting, but also it's just offered better rotational fit for growers in that environment. So where growers are trying to get back into winter crop pretty readily, that's obviously an important factor. Late plant sorghum also means that possibly you'll have to dry the crop, and there's a combination of basically clashing of time for winter sowing and sorghum harvest. It's important that you keep in mind that on average the yields have been about a tonne of the hectare higher than the long-term average for this environment. So while I did say out loud last year that I wanted some harder seasons, I probably didn't quite really mean what we had last year at Taluna, but it would definitely be good to have some data from the lower yielding end of the spectrum. But from the research that we've done to date, the yield has declined as your effective row spacing has increased. So the solid plant outyields the single skip and the super wide, which both outyield the double skip. If you're looking at your target plant populations, we still think you should be targeting that 30 to 50,000, probably more reliably the 50,000 at this point in time. And I think continuing to select hybrids with a level of tillering is always going to be an important mechanism for managing crop yields in our environment. And finally, as I've said, it's all about yield. So if we can improve the reliability and improve the yield, then it's going to mean increased profits. Finish up, this work is funded under two projects, as I've mentioned, sorghum in the western zone and the high yielding cereal agronomy project. So I obviously need to acknowledge a range of different trial cooperators, growers and many agronomists that have helped with site selection. Thanks to Pacific Seeds for their continued support of the sorghum in the western zone project, and thanks to the technical staff at Tamworth who always help out with this.